Welcome back, everyone, to the eCoreAcademy e-learning platform. My name is AJay Raj, back with yet another Algebra 1 video for you all. And today we're going to be focusing on the quadratic equation. As you can see on the screen, it looks like it's a very intimidating equation, but it does have very familiar roots with our quadratics that we've been covering, all about that quadratic function in standard form. And it's pretty simple to use, and it helps us out a lot in solving for x in a function. But before we get into this video, please make sure to do 4 things. Make sure to hit that subscribe button, turn on post notifications, hit that like button, and also feel free to leave a comment down below. So as I was saying, we're going to take a look at what exactly this equation is. What are these different variables like b, a, c? Why are we squaring things? Why are we square rooting things? I'm going to break this down for you, where it really comes from, and explain to you how we can use it to solve for x in a function when you're solving for your zeros of a function, like in standard form. Just like we did with completing the square or factoring, we're going to do the same thing to solve for x. So what exactly is the quadratic equation? So what's the purpose of the formula? Well, the quadratic formula takes different parts of only the standard form equation. Obviously, that's ax squared plus bx plus c in a quadratic function in order to solve for x. That x value is essentially your 0 or your what x intercepts. Those are the solutions for x. Whenever you cannot complete the square, essentially as our previous video, where you take half of b and then you square it, you add it to both sides, and then you essentially make it a perfect square trinomial. Whenever you cannot complete the square, maybe you have decimals, or it's not as smooth, you can always create obviously when you don't have integers, you cannot factor out the equation, obviously. So if you can't use the completing the square method, or you cannot factor it out, you can always go with the quadratic equation, meaning the quadratic equation is your third option. It's a little bit more complicated because you have more variables to plug in, but the success rate of it is it applies to just about anything. So you can always use the quadratic equation for any standard form equation if you want to solve for x. It works for any equation, unlike completing the square or factoring it out. Those are specific situations that you can use it in, but if it's a little bit more difficult of an equation, you can always use a quadratic equation, but it does take a bit longer. So we'll also take a look at how the formula was derived. So not only are we going to practice with using the formula to solve for x, but I'll show you where the formula actually came from. So let's take a look at the features of the quadratic equation. What are the different parts of it? So the different components in the variables. So this is the equation here, essentially x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this right here, our x value is our x-intercept, the value of x, or the zeros. So this can be one solution, two solutions, or zero solutions. Essentially, you can have two x-intercepts, one x-intercept, or 0. This right here is your b value. You're looking for the negative b value. That is essentially from the bx in your standard form equation, ax squared plus bx plus c. And this right here, this whole entire expression you're essentially taking the square root of this whole expression, b squared minus 4ac, and you're taking the positive and negative solutions of it. The reason being is whenever you square root something, you always have two solutions if it's a positive number. So in this case, if it's a positive number, you'll have a positive or a negative solution, just like the square root of 9. It's negative or positive 3. And over here, we're going to divide the top expression by 2a. A is obviously from ax squared, just as you see in negative 4ac. That's essentially what's being multiplied to x squared in your standard form equation. And finally, c, that's the constant c, what you're adding at the end of the standard form equation, ax squared plus bx plus c. Now, it's fairly simple here. All you're doing when you're solving is you're just taking those variables, knowing what variables you need from the equation, like a, b, and c, and then you're plugging it in place of all the a, b, and c's that you have here, and then just solving regular computation. So let's take a look at another property of this equation that has to do with the types of square root solutions. Now, remember, when you're taking a square root of something, it's a little bit more complicated to find the solutions because, first of all, we know that you cannot have a negative number, because if you have a negative number within a radical, well, you really can't find any proper solutions for that. No real numbers go in that place. If you have a positive solution, you can find the square root of the answer. However, you'll have two answers because you can have two negatives multiplied together to get that very square, or two positives. So you have a plus or minus. That's two solutions. Or you can have 0, which is a different amount of solutions. So in order to discover how many solutions you're going to have using this equation, you're going to use something called the discriminant. the discriminant. So what exactly is a discriminant? The discriminant is the part of the quadratic equation that goes b squared minus 4ac. What's inside the radical is the discriminant. Now, based off of what the discriminant is, if this whole expression here equals a positive number, you're going to have different solutions. If it equals a negative number, you're going to have different solutions. Or if it equals 0, you're going to have a different set of solutions. So if this expression right here equaled a positive number, that means you'll have two total solutions. So a positive and a negative solution for the square root of a positive number. You'll have two solutions. If it's the square root of a negative number, meaning of b squared minus 4ac, if you plug those values in from your equation, if that equals a negative number, you're not going to have any solutions for x, essentially, or x-intercepts. And then obviously, if you have a square root of 0, you're only going to have one solution, because square root of 0, that's only 0. No positive or negative 0, it's just 0. All right, so the discriminant, this specific part, if it asks you how many solutions, you don't have to go all the way through to calculate it. You just figure out what b squared minus 4ac is from your equation, and then you'll be able to find out how many solutions it has. All right, so now let's take a look at some simple practice. So let's find the x-intercepts for the function below. The function is f of x equals 5x squared plus 2x plus 3. Now, we're going to obviously refer to our equation. You might want to start memorizing these types of equations. Specific equations like the circle formula, quadratic equation, these things come very useful. So just make sure you try and memorize it with more practice. So x equals negative b plus or minus the square root of b squared minus 4ac. This is all over 2a. So now we're just going to identify what our a, b, and c are, essentially the three variables in this equation, and then just plug them in and calculate. So we know that our 5 right here, this is going to be our a value. This bx here, this 2 is going to be our b, and obviously 3 is going to be our c. And obviously, if you're a little bit confused or a little bit rusty on standard form, please make sure to check out our standard form video. That's going to be a few videos before this one, and it's also in our Algebra 1 playlist, so please make sure to check that video out. So let's start plugging in what we know. So we know that x equals, so negative b, that's going to be negative 2, plugging in 2 here, plus or minus the square root of, obviously b squared is 2 squared, minus 4 times 5 is our a value, and then 3 is our c value, so minus 4ac. Extend that radical. And then obviously that's over 2 times a, so 2 times 5. Now we can start to simplify, so x equals negative 2 plus or minus 2 squared is 4, negative 4 times 5 is 20, negative 20 times 3 is negative 60, so we're left with 4 minus 60 in this case, so that's going to be negative 56 in this case, all over 10. 2 times 5 is 10. All right, so let's shift this over here. Now we're looking to simplify in terms of, what might be able to go into this equation here. So we know that we can start off by dividing negative 56 by 2 because it is divisible by 2. So 25 times 2 is going to be 50, and then obviously adding that 3, you get 28. So we're left, and then within 28, you have to figure out, are there any perfect squares that go into 28? Well, there are 4. 4 goes into 28, so here we can simplify that. X equals negative 2 plus or minus, essentially, negative 28 times 2. Did you guys catch my mistake there? Yeah, you did. So essentially what's happening here is we just figured out that there are 0 solutions for this equation. Now, I made this mistake on purpose. I moved on to try and simplify what negative 56 was. However, there's no point in solving for this equation further because we know that there's going to be no solutions. This is going to be a square root of a negative, essentially, and that's not a physical reality. You cannot find the square root of a negative. So why do you need to simplify this? Because as soon as we discovered that our discriminant was a negative, we know that there's going to be no solution. So we found our answer. No solution. Bingo. All right, now let's move on to the next problem. So let's find the x-intercepts for the function below as well. So we have this function here, 4 equals 3x squared plus 4x. Obviously, it's not written in the traditional form. It's not in standard form yet. So let's first put it in standard form. So obviously that's going to be, we're going to literally just move our negative 4 to this side, and then we get standard form. So 3x squared plus 4x, and then subtract 4 from both sides, minus 4 equals 0, or f of x. Now, since we've done that, we have it in standard form. We can plug these values into our equation. So we get that x equals negative b is going to be our first term, so negative b is negative 4, plus or minus the square root of b squared minus 4ac, so 4 squared minus 4 times 3a times negative 4, which is our c, all over the value of 2a, which is 2 times 3. So we can go ahead and simplify that. So x equals negative 4 plus or minus the square root of 16 minus 4 times negative 4 times 3 is negative 12. Negative 12 times negative 4 is 48. So we can add 48 in this case. So negative 16 plus 48 all over 6. And in this case, we're going to get that 16 plus 48 is going to be equal to our 64 in this case. So negative 4 plus or minus the square root of 64 all over 6. We can simplify that, obviously. Negative 64 is a perfect square. So we're left with x equals negative 4 plus or minus 8 over 6. Now, we're not done here yet. We have to find out what the two solutions are because it's a positive. So in terms of finding what the solutions are, we're going to create an OR, essentially an OR statement here. So x can equal negative 4 plus 8 over 6. That's one of the solutions. Or x can equal negative 4 minus 8 over 6. So let's simplify this. So negative 4 plus 8 is going to be 4, and then 4 over 6 is just 2/3. So x can equal 2/3. And then over here, x, negative 4 minus 8, that's going to be negative 12. And then negative 12 over 6 is going to be negative 2. So x can equal 2/3 or negative 2. So those are the two solutions for x. And obviously we can tell, because it's a positive within the discriminant, our 64, that's going to be a two-solution answer set for x. So now we're going to end off the video by looking at what the creation of the formula is. So how exactly was the formula derived? Now you might be thinking, like, why is this formula so complex? How do you get to such a smooth answer, like two answers, like negative 2 and 2/3, with such a complex formula? Well, that's because the formula is directly related to the standard form equation. It's all interrelated. So let me show you. Literally, the formula, the essential formula of the quadratic formula, or the quadratic equation, was created off of the standard form equation. So we're taking the standard form equation, literally turning it into an equation. So a formula. So we start off with our essential standard form equation here. That's in standard form. And then all we're doing here is we're taking the standard form. The first step that we do is we're moving c to the right-hand side. We're subtracting c. Now, what we're essentially doing here is we're completing the square. That's what we're doing. We're taking the equation in terms of variables, and we're going to start to complete the square to try and get to our quadratic equation. That's how it's derived. So we're subtracting c from both sides, the first step that you do. So we're left with ax squared plus bx equals negative c. Then what we're going to do is we're going to try and divide both sides by a in this case, so that we isolate a. Remember, you always have to isolate x squared on its own, so you have to divide by a, both sides. So if you divide by a on both sides, you're left with ax squared over a cancels out, so you're left with x squared plus b over ax equals negative c over a, obviously. And then what you're going to do is you're going to start the next process of completing the square. Remember, completing the square, it's always b over 2, essentially b over 2 squared. That's how you get that third term of your perfect square trinomial. So we're going to take b over a, and we're going to divide that by 2, which is b over 2a. So we're going to add that to both sides, b over 2a squared. That's what we're adding to both sides of the equation. Now for the second half of it, we take that equation essentially, and we're going to factor it out. So once we factor out that x squared plus ba over x plus b over 2a squared, essentially, we can factor this out into x plus b over 2a whole squared. That's essentially what you're doing, just factoring it out. And that equals negative ca plus b squared over 4a squared, because you took b over 2a squared essentially, and you factored it, you multiplied it out, so you get b squared over 4a squared. And then afterwards, you're going to merely square root both sides, because now you have a perfect square on your left-hand side. So once you square root that, you're left with x plus b over 2a on your left-hand side. And that's equivalent to, now you can start to see the formula actually shaping up. That's equivalent to, we're taking b squared minus 4ac over 4a squared, and we're square rooting that, because if you essentially take negative c over a plus b squared over 4a squared, you add those together, you're going to take 4a squared and a, the common denominator there is 4a squared, so you multiply the negative c by 4a essentially to make that even. You add the numerators together, b squared minus 4ac, and that's over your common denominator of 4a squared. So then you square root that essentially, left-hand side, x plus b over 2a. That's equivalent to the positive or negative solution. Remember, whenever you square root, you get positive or negative solutions of the square root of b squared minus 4ac all over 2a, because once you square root that, you can essentially see, in this case, you're leaving b squared minus 4ac because you can't solve that further. However, the denominator you can simplify to 2a. And then the last thing to do is we're going to subtract b over 2a from both sides of the equation to isolate x on the left-hand side. So you're just adding negative b to the numerator because the denominator is already 2a. And you finally get your quadratic equation of x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So it's all related to the quadratic equation. Even if you're a little bit shaky with that, all you're doing is you're taking the quadratic equation, literally completing the square to find the solution of x in terms of the variables a, b, and c. All right, everyone, that'll be it for today's video. This has been AJay Raj here at the eCoreAcademy e-learning platform. Please make sure to like and subscribe, and check out all of our other courses and videos, like my sister Anita, the other founder here at eCoreAcademy. She has a lot of cool videos in biology, algebra 2, even in anatomy and physiology, so make sure to check all of us out. Check out our website at www.ecoreacademy.org. Email us if you have any questions at ecoreacademy@gmail.com. And also check out all of our socials at Pinterest, Facebook, Twitter, Instagram, and TikTok, and see what kind of cool content we have out there. All right, everyone, this has been AJay Raj. I hope you guys enjoyed this video, and I'll see you guys in the next one. Peace.